So welcome to another food focused webinar, and it's so great to have so many people on the line with us today. A very special welcome goes out to Karen Goodburn. Karen, thank you so much for joining us all the way from the UK. Karen heads up the Chilled Foods Association, so I'm delighted to have you with us. And I see there's a couple of lawyers on the line. That's also very interesting. Thank you for joining us. It's nice to have you on the other end of the presentation. I'm going to tell you a little bit about Hylton. You can see his face on your screen. So if Hylton's just going to take us through the presentation. He's currently the Managing Director of Technilamp in South Africa. They're a Bidvest company, and Hylton is actually a passionate marketing person. He spent a lot of his life marketing, but for a good few years now, he's been heading up Technilamp as the Managing Director and selling lots and lots of UV lamps and around the country in food producing companies as well as in hospitals. So it's really a great pleasure to have somebody as high up the food chain as the Managing Director of a business going through a presentation today. So Hylton, without any further ado, I'm going to hand over to you so that you can tell us a little bit about UVC and how we can use it in the food industry for microbial sterilization. Over to you.
Well, thank you very much, Linda. Welcome everybody. We just go to the slides. So UVC was first used in 1901 in Sweden in terms of a medical use, in terms of deep vein surgery. And nowadays it's actually been called an old science with a new life. After the Second World War, the chemical companies did a fantastic marketing job explaining how good that chemicals were, and UV started to take a bit of a back seat. But of late now, it's now known as the old science with a new life. One of the issues that we face, I don't know whether it's like that in the rest of the world, but in this country, there's very few formal varsity courses as such where people can graduate or do a course on the likes of UVC and its actual benefits. So we do battle in the market to actually get the word out as to how good, basically how good the likes of UVC is. Three types of UVC disinfection. There's air, surface, and water. Those are the three primary areas where we're able to operate. If you look at the next slide on the spectrum of where we sit, this is a Phillips chart, but if you can look under visible light, which is in the middle, now that's what the human eye sees. And to the left of that, you've got UVA and UVB, which we get from natural sunlight. And we operate in what's known as the 254 nanometer mark, which is the UVC, and that's just before X-ray. So that's where we operate in. In terms of its functionality, UVC lamps emit shortwave UVC, and it's at the 254 nanometer mark. And the way it operates is that UVC kills or damages the actual DNA, preventing it being able to replicate. The real benefits of UVC, and this is particularly interesting now, and we're finding more and more of this, whether it's in the fruit and vegetable industry or in the meat industry, is that it is chlorine free. As you know, chlorine has been used for many, many years, but there are millions of consumers out there, and you guys listening out of Europe and the US maybe would certainly know that most consumers now do not want their fruit or vegetables washed in a chlorine type of environment. The UVC lamps are effective up to about minus 15 degrees C, which makes them very effective in the cooling industry as well. The benefit of UVC as well is that it's a once-off cost. It's not as though you're using chemicals where you are incurring that daily cost. Also, depending on the amount of hours that you use these lamps, there's really only annual maintenance that is basically required. And we get results now of an extended shelf life on foods, anything between 4 to 21 days. And that is basically preservative free. And provided you actually design the type of equipment to be used that's perfectly safe for humans to actually work, basically work in that environment. The types of UVC disinfection, there's what's known as upper room air, which is used during working hours, and then there's direct, which is outside of working hours. So that's a very important point. UVC, if people are exposed to it with their eyes, people can get arc eye, which is almost like that effect that you get of looking into a welding machine. But we have systems where it is perfectly safe to work in what's known as an upper room air, which is during working hours, and then there's the actual direct UVC, which is for outside of working hours. UVC is not the panacea of everything. It has got basically one or two limitations, and the biggest limitation is that it's direct line of sight only. So in other words, if the UVC is shining onto a working table or an operating table, it will disinfect that surface area instantly, but will not disinfect under the table or else onto the floors. So it will only disinfect where the light is actually shining onto. If you look at surface, basically surface disinfection, it's ideal for food working surfaces. The lamps are basically positioned above as well as below. We've been doing some work of late where we are actually positioning the lamps above the workstations, but of late now we've been asked to actually put UVC lamps under the work tables as well, so they'll actually shine onto the floor, which I understand now of late that flooring is one of the worst cases when it comes to bacteria or any type of those things. So that's the third point there in terms of disinfection of working surfaces and floors. Just a very simple graphic of a surface disinfection. So the actual light is basically positioned on the roof or just above the working surface, and then whatever area that it displays the light, it'll shine on, and onto this case it's a carcass, but it could be a working surface of any kind. This is an example of a machine that we built a couple of years ago for a company that supplies Woolworths, what was known as the ethnic bread line, and they wanted to extend the shelf life of this ethnic bread line from about 4 days to 15 days, which we were very easily able to achieve. Now, just a couple of points about this. The actual machine has got 4 banks of lights. If you look at that stainless steel part at the back of the picture, there's a bank of UVC lights on the top, and there's a bank of UVC lights underneath. And the main point about this is that you'll see that there's a shield in front there, so there's no UVC light which is actually emitted there. The other point to actually consider here is that the actual conveyor belt has got large holes in it. Now, in this instance, we are able to basically design and order the type of conveyor belts that we want, and in this instance, you want to be able to expand to actually expose the bread to a maximum amount of UVC. So this has been operating now for about 2-3 years, operating very, very well in the market. Another point to remember about this is that you need to disinfect just before you do the packaging. So this actual machine is, the units are taken off there and put straight into a plastic packet and sent off and merchandised like that. This is another machine which we did for a company called Into Foods, and Into Foods exports around the world, but also does all the local work for Woolworths. And this is known as their small fruits, all the berries. And you'll notice that this is a very different type of belt, conveyor belt. So this belt was actually designed to ensure the very, very, very soft handling of these fruits. And it moves along on a belt that's about 9 meters long. And what this picture doesn't show is that there are actually rollers further up the belt where the fruit actually rolls over 2-3 times. So that's to ensure that the fruits are totally exposed to the UV. When it comes to air, disinfection of air, so this is a unit that we have put into factories as well. Now, this is a very important point now. This is the unit now that's used during working hours. So this is a unit that is put above head height, and it actually portrays an invisible ray of UV light. We've just done a simple drawing there showing how the air circulates. And the latest science is that one should actually put a couple of fans in around these lights if you were going to put them into the factory. And if you can picture almost like a drop of water, a splashing of water, where the air would then would be forced down onto the ground, and then it reverberates up into that UV captured area. The other point as well is that hot air rises, people cough, splutter, and the actual bacteria then rises and comes into contact with that UV lamp. And we have various sizes, one that would cover 36 square meters, ones with that would cover 25 square meters, and one that covers 12, basically 12 square meters. And we've got many thousands of these out in the workplace. This is a new invention we've just brought out now. We've sold a few units now. Because the lamps are able to operate up to minus 15 degrees C, and I think most coolers need to operate between 3 and 5 degrees C, or minus 3 and 5 degrees C. This is a unit that, as you know, those are those condensers which are then cooling everything in the fridge. And we've actually designed a new system now, a system which sits above those units and also at the back. And there's one of these units for every fan, and basically the air circulates many hundreds of thousands of times around and goes through those condensers and passes over the UVC lights. There's also no mold growth at the back of those condensers, and you've got clean, sterile air coming into those coolers on a 24/7 basis. This is another system that we've done for bakeries. As you know, bakeries are very warm places, and this is what we call our centralized air duct system, where you're able to calculate the size of the duct and the air speed flowing into the bakery. So this was a centralized air conditioning system that was being used to cool the bakery down. But in that stage, there was lots and lots of bacteria, and we were then able to cut into that UVC, into that air duct system, position a whole lot of lamps inside there and close it up, so the cold air passes over those UVC lamps straight into the bakery, and you therefore have clean air coming into the bakery. And that also prevents a lot of mold, obviously. Then this is a system out of Melbourne, and we've recently launched these, and this is a system that gives off a UV light and also just a touch of ozone. Now, as you know, ozone is a chemical, and the ozone then gets into all the areas where the meat is, where UVC will disinfect in its line of sight. This unit gives off a marginal amount of ozone, which then spreads onto the surfaces of all the meats and is particularly effective in the dry aging of meat. There are graphs illustrating that the dry aging can actually be extended from anything up to 10 to 22 days. And then last but not least, this is just a very simple picture of a water, basically a purification and a disinfection of water. And I don't need to tell you, there are many thousands of units of these, but in the meat industry, we are selling lots of these small units where they just want clean, sterile water to be used into the likes of sausages. And this is just a 3-filter system with a UVC light. So the water just flows through these 3 filters up into the UVC system, and then can be used as clean water. So those are the three ones. Those are the brief, just a brief summary of what UVC is capable of doing. I do believe if you're looking for a healthier option and you're looking for a long-lasting option without too much maintenance, and if you want chemical-free, I think UVC is definitely one of the options to be looking at. And I hope I've answered all the questions, but if anybody's got any questions, please feel free to put them forward. Thank you.
Thanks, Hylton. There are actually a couple of let's see whether we can assist in that respect. This is against mold, yeast and mold, as well as bacteria. I think the work that you've done, I'm breaking up. Can everybody hear me? Is that a bit better?
I can hear you again.
Okay, let's try again. One of the questions is UVC effective against bacteria as well as yeast and mold? In other words, are we talking pathogens as well as spoilage organisms? I think you answered that, because I think in some of the examples that you showed us, the use was against yeast and mold, but in terms of carcasses, you could also have pathogens, because the UVC it does not discriminate. It works on the DNA, or preventing the DNA replication within all cells. Am I correct?
That's right. Yes, yes, yes.
Okay, so someone's asking specifically, in terms of the work that you've done regarding Listeria. I know there are a number of papers that have been published using UVC in terms of Listeria. Is there any work? I know you've mentioned that you're working with Stellenbosch University in that regard, and Professor Khosa's input in this respect.
Yes, yes. So we've done some work in the fish industry with that, and we're also doing some work in the avocado industry. Yeah, yeah.
Okay, and specifically targeting Listeria in that regard.
Correct. Yes, yes.
Okie dokes. Then in terms of the combination with ozone, there's obviously some concern regarding the application of ozone where people are working. How do you manage that aspect when you put a combination unit together?
Okay, so there's basically two ways of doing it. First of all, the levels of ozone are quite low and they're not dangerous to humans. The other thing is that when these units are installed, there is a dead man switch which is put on the door, so they actually switch off when people walk in, and then go on when people close the door again and they've actually exited the cooler.
And the same would apply with some of those UV lights, where it's obviously not safe for people to work. They're used after hours as opposed to during operation.
Yes, so in the fish industry now, and in a couple of the meat industries now, they have UVC, and also in the nut industry, they have UVC lights now which come on after hours. Let's say at about 4 o'clock in the morning, and they're switched on for 2-3 hours, and they switch off at 6 in the morning, but they make sure that there's nobody in there. Yeah, and there's no humans in the work area. Yeah.
So when you mention time, I mean, if the lamp is on for 2 hours, is time a factor to ensure effective sterilization? Is there a minimum amount of time?
So that's a very good question. So in the industry, that it's known as dwell time. So how much time do you need to kill the different types of bacteria? And those dwell times do change. They definitely do change depending on the type of bacteria. And there are theory books where one can look up as to the dwell time that you need. But yes, there are different dwell times that are definitely required. Yeah.
Okay, so I think in terms of if the UV step had to be used as a CCP, in other words, it's, as part of our HACCP plan, we're actually using it as a critical control. There would be a number of factors. Obviously, we're talking about a very specific wavelength. The strength of that wavelength is quite important, but the time of exposure to that wavelength must also be measured to ensure that we are, in fact, getting effective sterilization or effective kill in terms of the organisms that we're targeting.
That's absolutely right. Calculations are done, but you can generally work on, some are pretty instant, literally within a second or two, but you would generally kill most of them within about 20 seconds. That's when you've killed most of them. Yeah.
Okay. All right. What about spores? So, I mean, you know, some organisms have the ability to form spores. Does that require, I mean, if we're working with a bacillus species, for example, where we know we may have an endospore, does that affect the calculation?
I've never had that question. I must say, I would probably need to check that one out before I gave you a candid answer there. I probably need to.
Okay. Yeah, I think it's a, you know, it's an important one in some processes, but I think it would also depend on what the application is. Yamish is asking a question about liquid products. I mean, you've mentioned water, milk. I know this, you know, we've chatted about the work that's been published. In fact, that was work that was done by Stellenbosch University when it comes to, you know, using UV as an alternative to pasteurized milk. Am I correct?
Yes, I haven't seen that work. As I always remind people that UVC is able to penetrate surfaces only, and you know, milk is quite dense. So, and orange juice, you know, the juices are quite dense. But clearly, there has been work done there where they're able to prove it. Yes, yes. But I haven't seen. I mean, I haven't read the actual paper. No.
Yeah. Okay. Yes, I know. I am aware that there's a number of papers, but what you're saying is you haven't done that specific application in South Africa.
No.
Okay. But in terms of surfaces, that's obviously where you know that you've had a lot of success.
Absolutely. Yeah.
Okay. Now, I think one of the interesting things is you mentioned the bandwidth, or sorry, the you know, whereabouts you're actually working in terms of the scope of light. Do you play around with that, Hylton, or is it always specifically around 254, or is it, you know, can it go higher than that or lower than that? Is there a specific range that you would be using in terms of wavelength?
No, definitely not. So we only use Philips lamps. You know, you can get a General Electric lamp or an Ozone lamp or anything like that, but we generally use Philips lamps only. But there's an international standard on it, and it sticks at the 254 nanometer mark. Yeah.
Okay, all right, that's interesting, because just again, in terms of, you know, some of the reading that I've done, I have seen that there could be other wavelengths that are being used as well, and it's just interesting to, you know, to understand why there would be if there would be a change, or if there would be a need for a different wavelength, particularly with regards to, you know, the spore formers. Would it be necessary to use a slightly different wavelength? And I think we're all familiar with using UV. I mean, I think most of us probably use it when it comes to killing flies, or in terms of pest control. And we're always told that we need to change the lamps once a year. You know, does the same apply? You mentioned maintenance. I mean, you know, what happens to the beam in terms of, is it the intensity? You know, what is it that happens that it needs to be replaced on an annual basis?
So that's a great question. So most high quality UVC lamps, and I must stress this word because there are cheap UVC lamps available, but if you get them from the main brands, the likes of Philips and Ozone and all that, they have a lifespan of 9,000 hours, which is basically 1 year. So if the lamp is exposed for 24/7, it's going to last you 1 year. If you're in the factory and you may be switching them on at night and it's on for maybe 8-9 hours, well, then the lamp's going to last basically 3 years. So the cost is very, very low. But the most important thing about this is that UVC lamps, when they stop giving out when they stop radiating, they will actually continue to glow. So it gives this false sense that the lamp is working, meanwhile it's not functioning at all. So it really is important to have a very good maintenance program, and with times and dates are kept as to when the lamps were actually switched on and how long that they're being used, so you are able to change them at the right time. Otherwise, it just gives a false sense of security. Yeah.
Absolutely, and I think coming back to the question we had around the CCP, that would be one of the very important factors that we would have to take into account. There would need to be, a specific record relating to the number of hours that the lamp has been in use in order to ensure that we do still have an effective beam. We have a question from Portugal, Hylton. So thank you, Andre. What about, yes, there's a lot of work that's been published regarding the effectiveness of UVC, and Hylton will be assisting me with an article post this webinar in order to give you some references. Andre's question from Portugal is, what about PVC cups for packaging food liquids? So in other words, if prior to packaging, if you are to disinfect the packaging itself, Hylton, have you had any experience in that application?
Oh yeah, very much so. So a UVC will not penetrate through plastic or glass, but if you're in the packaging industry and you need to sterilize the necks, and this is very important in the bottling of water, but if you need to sterilize the necks and also the caps, and then you can also sterilize if you're putting food into the plastic sleeves, you're then able to sterilize those plastic sleeves just before you fill them up and then seal them. So we have done work where we sterilize the plastic cups as well as the lids just before they are sealed. But yeah, so it basically disinfects everything around it, but it won't penetrate once it's sealed. Yeah.
Okay, and I think Karen's asking a related question in terms of UVC obviously can be, cause degradation of plastics itself. So in terms of, the tray, I mean, you're obviously subjecting the packaging material to the UVC for a short period of time prior to being used, so immediately prior to being used. But is there a concern regarding, it actually creating wear and tear in the facility, particularly relating to plastic items?
No, I can categorically say no. And the reason for that is that UVC needs time to actually degrade the product, degrade that tray or that plastic. And if depending on the level of intensity of the UV lights, because you do get very, very powerful lights, but in essence, you would degrade that product if it was given a 24/7 exposure. You would probably degrade that tray within about 3 weeks to a month. So the couple of seconds that it's under that UVC, basically that UVC light, there is no effect whatsoever on the tray.
If I'm using a food container though, and have got food in that, for example, instead of on a conveyor, and that tray is going through the beam on an ongoing basis, there may be a chance that with time that plastic would degrade. But if we're talking about single-use plastic for packaging, then you're saying the time there would not be sufficient to cause degradation.
That's great. So the answer to that is we have done work in food factories where we've asked them to change the actual plastic conveyor belts and change that to stainless steel, because that's definitely the long-term answer. Because
okay, great. I think that's one. Okay, then another technical question in terms of what about voltage fluctuations? So we do live in the bottommost parts of Africa, and aside from Eskom and power surges and load shedding, how sensitive are they to voltage voltage
They are normal lights and subject to it, very much so, and we often find that the ballasts go and that we have to replace the ballasts. But the voltage fluctuations do actually affect the lamps, yes.
Okay, so it's something to be aware of from an ongoing maintenance perspective. Okay, what about spice irradiation? So currently we're using, I think it's gamma rays for spice irradiation. Have you done any work using UV as an alternative?
No, we haven't. And once again, I'll get back to that. UV is capable of disinfecting surfaces.
Yes.
So we have done work on the likes of vibrating feeders, where the spices are stretched and very, very thinly on the vibrating feeder. But I can't sit here and say to you that we've actually built a machine and put it into the market. No.
Okay, but there's some.
But it can work. It can work.
Yeah. Yeah, it obviously sounds like it could be a feasible option, but there would need to be some validation done. What about ready-to-eat products, Hylton? Somebody's asking a question with regards to pies. You know, obviously in the cooling process of pies, you can have some condensation, and if there's yeast and mold, then obviously we get green and furry pies. You know, have you had any done any work on that kind of product where it's actually put through the process prior to going into the packaging, and the packaging sheet prior to it actually, you know, forming over the pie?
Yes, if you look at that bread example, that ethnic bread, yes. So the UVC is able to disinfect any surface just before it goes into the packaging, yes, and that it will definitely give it an extra shelf life, yes.
I'm sure Hylton will be happy to take any other questions directly, wouldn't you, Hylton?
No problem. Yeah, sure, please. Yeah.
Super. Thank you very much, everybody. Thank you for joining us today. Thank you for bearing with us during the technical hitches. And also just to let you know that I will edit and send you the updated presentation without all the bumps and lumps in the beginning, so that you can share it with your friends, you can share it with your colleagues. And please do get in touch with Hylton if you have any more specific questions. And look out for that article where we will give you some very specific published references where you can go and check up you know, the science behind it, and also have a look at the other research that's been done.